Okay, so if you can see and you can hear, can I see your response? Just indicate if you can see or you can hear. Sorry, there was a disruption in the previous live class. Right, so we are back again. Network disruption in the previous live class. We are back again. So tell me if you can see and you can hear. All right. Tell me if you can see and you can hear. I need your responses if you can see and you can hear. All right, so quickly let's proceed. So we have partial fractions here. In this class we are going to be looking at some relevant calculator shortcuts and also some exam focus areas in algebra and trigonometry. Now we have some partial fraction questions here. As you can see, there are about 4 of them. I'll be showing you the calculator shortcut on how to resolve these partial fractions. Now if you want to actually get the knowledge of partial fraction, you can watch my video on this channel. If you've not subscribed, hit the subscribe button right away and subscribe to this channel. All right, so quickly we are going to be looking at each of the questions. Now how do you resolve partial fractions using your calculator? All right, so quickly I'm going to be exposing that to you. Now the idea is that the first thing you must do is to clear your calculator. How do you clear your calculator? It's very easy. So you press shift, you press 9, you press you press shift, you press 9, all right, you press 3, then you press equal to, and you press AC, and you press AC, your AC button. All right, so yes, it will be available to watch later. If your network is disturbing, you can watch it later. All right, so let's proceed. All right, so now how do we resolve? After clearing your calculator, I say how to clear your calculator. You press shift, press 9, press 3, press equal to, then press AC. Shift 9, 3 equal to, then AC. Now the reason why you clear your calculator is so that if x is stored as a particular value, it will not affect your answer. Now if you look at it, we have questions here. Look at number 1, then see options. Now how do you resolve partial fractions using calculator shortcut? I'm going to explain that now. All right, so now I believe we are together. Okay, so now the approach is this. The first thing is to plug in your question. Okay, plug in your question in the calculator. How do you do that? How do you do that? All right, you press box over box because it's a fraction, so press box over box. So the up side, which is the numerator, have x plus 3. So how do you get x plus 3? You say alpha, then bracket close, x, then plus 3 divided by open bracket and our bracket, press alpha again, then x plus 5, close the bracket, then all squared. Now if you look, we're having 3 over 25. So now write that 3 over 25 somewhere. Write it somewhere, 3 over 25. Now it's not as if this is the answer, or this is not the answer. All right, the reason why you are writing this is because now you want to actually test your options. Anyone that gives you this 3 over 25 is your answer. Anyone that gives you this 3 over 25 your answer. If you look, I have already ticked B because I've already explained this in a video before. All right, so B was actually the answer, but I'm just trying to re-explain it again. All right, so when you test each of your options, anyone that you get 3 over 25 from is your answer. Are you seeing how easy it is? All right, so now let's check the first option. The first option here is 5 over x plus 5, alpha x plus 5. All right, then minus 3 over bracket alpha x plus 5 all squared. As you can see, what's the answer here? 22 over 25. All right, 22 over 25 is the answer. Okay, so 22 over 25 is not the same as this 3 over 25 that you got when you plugged in the question. So what do? You check the next option. So the next option here is you bring your box over box again. You say 1 over alpha x. To get x, now you press alpha and bracket close, then plus 5, then minus. The reason why you're using 2 box over box, bring another box over. The reason why you're using 2 box over box is that you have two two fractions. That's why they're called partial fractions. All right, then you have 2 divided by bracket open alpha x plus 5, close the bracket, then all squared. Now if you look now, we're having what? 3 over 25. That's why this is the answer. Now the thing is this, all these options cannot give you, in fact 2 options cannot give you the value that you will get when you plug in your question. Only one option, and that one option will be your answer. It's not as if 3 over 25 is your answer. That's what I'm saying. All right, I'm saying 3 over 25 is not your answer. 3 over 25 is actually the numerical value that compares the actual fraction with each of the options. That means when you substitute x as 0, okay, when you substitute x as 0 and you plug in here, okay, plug in here, then you plug in to this particular option, okay, this particular option, it will give you 3 over 25. So both of them are giving you 3 over 25 because this is actually the partial fraction of this. All right, this is actually the partial fraction of this. That's why. Okay, that's why. All right, let's go to the next question. Okay, the next question is this. Now another way, without calculator, another way of doing it is that put, like I said, put 0 in your partial fraction, then put 0 in each of them. Anyone that gives you the same answer with the answer that you did here, anyone that gives you the same answer among the options. Now see what I mean. Now if I plug 0 here, we have 0 plus 3 over 0 plus 5 all squared. This will give us 3 over 5 squared, which is 3 over 25. If I plug in this option now, this one that we say is our answer, 1 over 0 plus 5 minus 2 over 0 plus 5 all squared. This will give you 1 over 5 minus 2 over 25. LCM here is 25. So 25 into 5 is 5. 5 times 1, 5 minus 25 into 25, 1 times 2, 5 minus 2 is 3 over 25. All right, 3 over 25. So that's it basically. So like I said, plug in this question. All right, plug in this question and plug in this question, whatever you have as the answer in the calculator, write it somewhere, then test each of the options. Anyone that gives you this particular answer is your option. Just stick it and go. All right, then now let's try the next one. The next one is 2x plus 1. So bring your box over box. All right, bring your box over box. Then we have 2x plus 1. So we say 2 alpha x, then plus 1, come down, open brackets, alpha x minus 3 all squared. All right, what is it giving us? 1 over 9. So just write your 1 over 9 somewhere, write 1 over 9 somewhere, then begin to test each of these options. Anyone that gives you this particular 1 over 9 is your answer. So test each of the options. All right, so let's do that. Let's test this one first. So box over box, then we have minus 4 divided by alpha x. This, remember, this is your x. This is where you have x. Look at it written here. So alpha x minus 3. Alpha x minus 3. Then minus, bring another box over box. So we have minus 6. Okay, no, remove this minus. It's just 6. Then come down, open brackets, say alpha x minus 3 all squared. Are you saying that we're having 2 over 3? So this is not the answer. Check the next option. So the next option is minus 2 divided by alpha x minus 3 will go up plus 7 divided by alpha x minus 4. Okay, this is in brackets. Put it in bracket. Then square. I see it's giving us 53 over 48. We have not gotten 1 over 9 here too. Then I'll check the next option. Next option here is minus 2 divided by bracket upon alpha x minus 3 all squared. Then plus 7 divided by bracket upon alpha x minus 3 all squared as well. You can see 5 over 9. It's not giving us 1 over 9. Let's check the last one. So it will most likely be the last option. If it's not the last option, it means that the option is the correct answer is not in this question. So now let's check the last option. So we have 2 divided by alpha x minus 3 then plus box over box again, 7 over bracket open alpha x minus 3 bracket close all squared. Are you seeing that? 1 over 9. So it means our answer is what? D. Okay, our answer is D. Now let's check number 3. So number 3, the question here is bring box over box. So alpha x minus 3 minus 2 alpha x squared. All right, minus 2 alpha x squared divided by alpha x squared bracket alpha x then minus 1, close the bracket. Okay, are you seeing? We just plugged in this. So what is it giving us? Okay, let's check. Okay, this one is giving us math error. Okay, let's rearrange. Say let me start from 2x squared. So let's say 2 okay minus 2x squared then plus alpha x then minus 3. Okay, so it's giving math error. Okay, it's giving math error. Okay, let's check. So if it's giving math error like this, then it means that the question, the partial fraction itself is wrong. Okay, that's what it implies, that this one is wrong, because no partial fraction, no actual fraction is supposed to be giving you a math error in your calculator. So now let's keep to the last one. All right, so let's keep to the last one. So we have 3 divided by, okay, bracket open x plus 1. So say alpha x plus 1, then another bracket alpha x minus 2 all squared. So as we plug this now, what are we getting? 3 over 4. So write 3 over 4 somewhere, then test each of the options. Anyone that gives you 3 over 4 is your answer. All right, so let's test each of our options. Let's start with option A. So option A, box over box, we have 1 over 4 bracket alpha x plus 1, close the bracket, then come up, put minus, bring another box over box, 1 divided by 3 bracket alpha x minus 2, then plus, bring another box over box, 2 divided by alpha, okay, we have brackets there first, alpha x minus 4 all squared. All right, see what is giving us? 13 over 24. It's giving us 13 over 24. That's not 3 over 4, so it means that A is not the answer. Now let's check the second option. Second option, we have 3 divided by 2 brackets alpha x plus 1, then come up, we have plus box over box, 2 over 3 brackets alpha x minus 2, close the bracket, then come up again, say plus box over box, 5 over bracket open alpha x minus 3, close the bracket, then your squared. As you can see, it's giving us 31 over 18. It's still not 3 over 4. Now let's check the third option. So you have to be checking like that. 1 divided by 3 brackets alpha x plus 1. The reason for this shortcut is that partial fraction resolution, resolving partial fraction tends to take time. So in order for you not to spend much time solving this, it's best that you use this calculator shortcut so you can be able to get your answer quickly. So as you can see, this one is giving us 3 over 4. So it means that our answer is option C. All right, so that's how to use calculator to actually solve for partial fractions. All right, that's how to use calculator to solve for partial fractions. So now quickly we'll be going into complex numbers. Okay, calculator shortcuts for complex numbers. Now complex numbers are actually denoted as Z. All right, and it is equals to a plus bi. Sometimes you can see Z equals to x plus yi. Now this part here you're seeing is called the real part. This is the real part. Why this is the complex part. This is the real part, then this is the complex part. Now this real part is usually a number. For instance, now we can have z equals to 5 plus 7i. These x and y are usually numbers. A and b are usually numbers. This plus or minus, which means that it can be also z equals to, let's say, 4 minus 9i. This is how you to represent complex numbers. So we are going to be looking at how to add complex numbers, how to subtract complex numbers, how to multiply complex numbers, and how to divide complex numbers. Addition, subtraction, multiplication, and division of complex numbers. So I'm going to be teaching you the calculator shortcut approach, as well as the manual aspect Okay, then we will look at shortcuts. Now let's start with addition. Of complex numbers. Now let's say we have something like this. Say we are to add two complex numbers. Let's say we have 5 plus 8i, okay, plus 3 minus 9i. We have something like this. Now how do we solve this? Now it's very simple. So what we do is to open this bracket. So when we open the bracket, we have 5 plus 8i, then plus 3, plus times minus 16 minus 9i. What we do is to collect like terms. 5 plus 3 is what? 8. Okay, plus 8i minus 9i. 8 minus 9i is what? Minus I, which is minus 1i. So 8 minus I is the answer. You have 8 minus I. This is your answer. Alright, this is your answer. Okay, so 8 minus I is your answer. So how do you use your calculator to actually solve something like this? Now it's very easy. Now first of all, set your calculator in complex mode. So press mode. First of all, clear your calculator, right? Because remember, you did something before, but just clear it. So clearing is not going to take your time. Just shift 9 3 equal to then AC. Like I said, shift 9 3 equal to then AC. So press mode, then complex is number 2. Press 2. You saved your calculator in complex. As you can see now at the top is written complex. Alright, the reason why you save your calculator in complex is that so when you press this guy here, this ENG, I will come out. If we did not set our calculator in complex, let me go back to what it was before, and I'm pressing this, nothing will come out. Are you seeing it? Because it's not in complex. But what do? I change it to complex, press 2. Then if I press here, look at I. Is this I now that is your imaginary number, which is imaginary part? This is imaginary part. This I is the imaginary part. Alright, so how do we solve this? So simple. We put our first complex number. So open bracket, we say 5. Look at it. So we say 5 plus 8i. Look at your I here. 8i. Close the bracket. Alright, then plus, open another bracket, 3 minus 9i. Close the bracket. Look at your answer, 8 minus I, and that's what we got. Okay, you see how sharp it is? 8 minus I. You see how sharp and fast it is? So that's for addition of complex numbers. So now let's look at another exercise for that will have to do subtraction. So now let's say we have 7 minus 10i, then minus bracket open 4 plus 7i. Okay, having something like this. How do we solve this? We open the bracket. Okay, so we have 7 minus 10i. Open this bracket. This minus will affect this 4, so we have minus 4. This minus will affect plus. Remember, plus times minus is minus. Minus times plus is minus. Plus times plus is plus. Minus times minus is plus. So this minus now will affect this guy inside the bracket. So we have minus 4. Minus times plus minus 7i. Alright, minus 7i. So that's the strategy. Okay, that's the strategy. So what we'll do, we collect like terms. So 7 minus 4 will give us 3. Minus 10 minus 7 will give us minus 17i. Alright, so the answer is 3 minus 17i. How do you do that with your calculator? Very simple. So what do? We open bracket, we say 7 minus 10i. 7 minus 10i. Close the bracket, then minus, open another bracket, 4 plus 7i. Close the bracket. Are you seeing what we have? 3 minus 17i. Okay, 3 minus 17i. So that's what we have here. So that's what we have here. Are you seeing how easy it is? All right. So now the next thing now we will be looking at will be products. All right, will be product. So let's say we have z1 equal to let's say we have a question. We have z1 equals to minus 4 plus 9i. Then we have z2 equals to 10 minus 12i. Then we say find z1 z2. What they mean is z1 z2. What they mean is that find the product of this, that is multiply this by this. So how do you arrange that? This means minus 4 plus 9i times 10 minus 12i. This time you will not have plus or minus in between because they are multiplying. So what do? Multiply this by this. It's just normal expansion. Minus 4 times 10. Okay, minus 4 times 10 will give you minus 40. Minus 4 times minus 12 will give you about 48. 12 times 4 is 48, right? 12 times 4, that's 48. So minus is plus. So you have plus 48i. Okay, then 9i times 10 will give you plus 90i. Then 9 times minus 12. 9 times minus 12 will give you minus 108. 9 times minus 12 will give you minus 108. So this 9i times minus 12i will give you minus 108i squared, because I times I is I squared. Now please note this. I squared is minus 1. That is the value for I squared. Minus 1 is a standard value all times. So what do you do now? Collect like terms. All right, collect like terms. So we have minus 40 here, which is alone. There's no other constant. 48 plus 90 should give us 138. Let's check. 48 plus 90, 138. All right, 138. So it means that we have plus 138i, because these are like terms. Then minus 108. I squared is minus 1, so you substitute minus 1 here. So this will be minus 40 plus 138i. Minus is plus. We have plus 108. All right, plus 108. So now you can collect like terms. Minus 40 plus 108. These are now like terms. You can collect, you say minus 40 plus 108. So this will give you 68. So we have 68 plus 188i. That's our final answer. So how do you do this with your calculator? Simple. Just put in this guy. Just put in this guy. So open bracket, say 4 plus 9i. Close the bracket. Open another bracket. 10 minus 12i. Close the bracket. Okay. Let's okay, here we have minus. Mind you, we should be careful with our signs. Okay, are you seeing 68 plus 188, 38i? See, does it know what we got? That's what we have in our calculator. All right, so we just plugged in this question into the calculator and we got this. How many seconds? It not even take me up to 5 seconds to obtain this. But look at the time that it took me to solve this. All right, look at the time it took me to solve this. Okay, so that is the approach. That is the approach to partial to complex numbers, especially this is the multiplication. All right, so now let's imagine now that still with these complex numbers, we are also told to find z1 over z2. That is, we are told to divide. All right, z1 over z2, I told you, is division. All right, so how do we navigate through this? What it means is that z1 will be at the top, so it means that we'll have minus 4 plus 9i, then divided by 10 minus 12i. This is the expression. So how do we solve this manually? Let me flip to the next page. So we have minus 4 plus 9i, then divided by 10 minus 12i. So how do you solve this? Basically, what we do is to multiply by conjugate of denominator. So conjugate means changing the sign of this denominator, only the denominator, then multiply through. See what I mean? Minus 4 plus 9i, over 10 minus 12i. So you now multiply it by this denominator, changing the sign here to plus. If it was plus, you change it to minus. So we have 10 plus 12i divided by 10 plus 12i. Okay, so the idea now, this is not minus, so we just have 1 here. Okay, this 10 plus 12, I change only this guy to plus. So multiply this by this, this by this. Like I said, it's only the denominator that you are picking. You're taking the conjugate of the denominator, which means that you're changing the sign. Okay, which means you're changing the sign. So multiply this by this and this by this. So now put this in brackets, put this in brackets. So multiply by expansion. Minus 4 times 10 will give you minus 40. Minus 4 times 12 will give you minus 48i. That is minus 4 times 12i minus 48i. 9 times 10 will give you plus 90i. Then 9 times 12 will give you plus 108i squared. That is 9i times 12i. Here 9i times 10, 90i. Then divide now by, do the same thing here. 10 times 10, 100. 10 times 12i will give you plus 120i. Minus 12i times 10 will give you minus 120i. Then minus 12 times plus 12. Minus times minus. Minus times plus rather is minus. 12 times 12 should be 144. Then I squared. Let's confirm. 12 times 12 is 144 now. You just have to be sure sometimes. Alright. So now collect like terms at the top here. So minus 40 is alone. So we say minus 48 plus 90. So minus 48 plus 90 should be about 58 or so. Minus 48 plus 90. Okay, minus 48 plus 90, is it 48? Okay, yes, minus 48 plus 90 is 42. So plus 42i, alright, then plus 108i squared divided by, collect like terms here as well. We have 100 plus 120i minus 120i is gone, 0. So we have minus 144i squared. So remember that i squared means minus 1. So this is minus 40 plus 42i plus 108 times minus 1 divided by 100 minus 144 times minus 1. So now let's do the solving. So remember this I, okay? So we have a minus 40 plus 42i plus 108 times minus 1 will give you minus 108 divided by 100 minus is plus, so 144. Okay, so now collect like things. Minus 40 minus 108 should give us a minus 148. Let's check it. Minus 40 minus 108. Minus 40 minus 108 minus 148. Okay, then divided by 100 plus 144 is 244. 244. Okay, remember we have I here plus 42i. Okay, so it means that we have to now break this down. Okay, we have to break this down. So we have minus 144. We have minus 1448 rather divided by 244 plus 42i. There's a common denominator here all over 244 as well. All right, so there's a common denominator there. So what we just have to do now is to split that. So it's very important for us to understand that when we have something like this, we have to break it down into the simplest form possible. All right, the simplest form possible. So one thing is this. All right, don't forget that when you are solving, you have to solve to ensure that you multiply by the conjugate. That's the rule. So now let's break this down. All right, let's break this down. So let's say minus 148 divided by 244. So we can break down. So we have minus 37 over 61, then plus 42 divided by 244. 244 will give us 21 over 122. Then we have I. This is supposed to be our answer, but let's confirm. Let's use shortcut method to actually check. All right, so we have box over box. Minus 4 plus 9 plus 9i. This is 9i divided by 10 minus 12i. All right, so are you seeing what it's giving us? Minus 37 over 61 plus 21 over 122, which is exactly what we solved. So you see how long did it even take us to use this calculator? Are you seeing how very fast? But we have been solving this, or breaking this down. But it's also important for you to actually know how we solved this. It's actually important to know how to solve this and break it down like this, just in case it's not a not an objective question. If it's not an objective question, they will need you to show working. So it's important to show working. Like I said, multiply by the conjugate of your denominator. All right, multiply by a conjugate of your denominator. Carefully solve, expand, collect like terms, substitute -1 as I squared until you get your final answer. All right, to get a final answer. So that is that. So now the next shortcut, the next thing we'll be looking at is modulus and argument of complex numbers. All right, so modulus is denoted as mod z, while argument is denoted as arg z. All right, so how do we solve for modulus? So modulus is equal to square root of x squared plus y squared. All right, x squared plus y squared. Your x is your real part, your y is your imaginary part. So now let's say you want to actually determine the modulus of a complex number. Let's say the complex number is z equals to 7 minus 16i. Okay, how do we find the modulus of this? So mod z will be equals to square root of, now take this complex part, take this real part and square. So 7 squared plus, what is the imaginary part? You're only taking the coefficient of the imaginary number, which is -16. So plus -16 all squared. All right, plus -16 all squared. Ensure that this minus is inside the bracket, because the minus is for 16. This plus is always plus. Look at it now, plus. All right, so this will now be root 7 squared is 49. Okay, plus -16 all squared. -16 all squared minus 16 squared is 256. So 256. So square root of, so 49 plus 256. So that's giving us 305. So square root of 305. Let's check it. So let's check square root of 305. So it will give us, press this if you want to get the decimal. Always press this SD guy. So our answer is 17.46. So that's our modulus. All right, so that's our modulus. Now then, how about if we are told to find the argument? Arg z is equal to, the formula for arg z is tan inverse of y over x. Tan inverse of y over x, which means that we are actually looking for the argument here. All right, and the argument is usually in degrees. Okay, argument is usually in degrees. So how do we evaluate this? Now this y is your imaginary part, don't forget that. This is your x, y this is your y. This y is your imaginary part, y this x is your real part. Sometimes they use b over a. B over a is the same thing as y over x. All right, so the imaginary part, the coefficient of your imaginary part is your b or your y, while your real part is your x or your a. So what do you do now? If you want to find the argument of this, now this will simply be tan inverse of, what is our y? -16 divided by what? 7. So now let's do it quickly. So how do you get tan inverse in your calculator? Very simple. So you press shift this time, don't press alpha. Okay, so press shift, then press tan, press shift and tan, then press box over box. Okay, press box over box, then press -16 over 7, then come down 7, then close. What are you having here? -66 0.37. So your answer is minus 66.37. all right, so minus 66.37 is your answer. All right, minus 66.37 degrees is your answer. So basically you divide your imaginary part by the real part. Okay, divide your imaginary part by the real part. Like I said, tan inverse is shift and tan. Then you press box over box. Okay, you press box over box. Then you put minus 16, then over 7, close. Okay, all right. Let's do it again. Shift tan minus 16 over 7. All right, are you seeing it? Okay, so that's it. Basically, that's how to get your argument. So basically, this is everything you should know about shortcuts involving complex numbers. All right, so you need to know, like I said, the addition, subtraction, multiplication, division, then modulus, and argument. So if you've known this, if you've actually understood this very well, then it will not be difficult for you to actually solve questions or solve exercises that relates to complex numbers. All right, that relates to complex number. Now another one I'm going to be showing you is calculator shortcuts for permutation and combination. So calculator shortcut for permutation and combination. All right, so now look at this. Now permutation is the different ways you can actually arrange things. Combination is how to combine things. All right, so let's say the formula for permutation, we have you see something like npx. Now the formula now is you having n factorial divided by n minus x factorial, then x factorial, n factorial all over n minus x factorial, sometimes this x is usually replaced with r. Sometimes you see npr. All right, it's usually n factorial divided by n minus r factorial, then r factorial. It's best to actually use this. Okay, then combination is n. Okay, sorry, there's no r factorial here. All right, that is for combination. Okay, combination is n factorial divided by n minus r factorial, then r factorial. Okay, are you seeing it? So is this one that has another factorial of r? This one is just n minus r factorial when you have n factorial at the top here. Okay, when you have n factorial, then n minus r factorial. So now basically look at this. If we have something like this, let's say 5 permutation 4. This means you have 5 factorial divided by 5 minus 4 factorial to get the permutation. So this will be 5 factorial means 5 times 4 times 3 times 2 times 1. Anything factorial means from that number, multiplying from that number to the number less than it down to the least number. Now divided by 5 minus 4 is 1. So 1 factorial is just 1. Okay, because you don't do 1 times 0. So this will be 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. So you have 120 over 1, and 120 over 1 is 120. All right, 120 over 1 is 120. So that's how to solve for permutation. I'll show you the calculator shortcut for it. Then combination. Now if let's say we have 8 combination 2. All right, this will now be, see, combination is 8 factorial divided by 8 minus 2. Remember, your n is this value here, your r is this value, n is this value, r is this value. So you say 8 minus 2 factorial, then 2 factorial again. After, it's not like permutation that when you have written n minus r, you just stop like that. No, in combination you still put your r factorial. So now it means that we'll have 8 factorial. 8 times 7. I told you that you multiply by the next value. After 7 is 6 times 6 times 5 times 4 times 3 times 2, then times 1, divided by, what is 8 minus 2? 8 minus 2 is 6. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, then times 2 factorial. 2 factorial just 2 times 1. So what can you do here? You can actually cancel. You can cancel these 6 times 5 times 4 times 3 times 2 times 1 by this other one. You can cancel them. So you'll be left with 8 times 7 times 6 divided by 2 times 1. Now 8 times 7 times 6 will give you what? 336. So 336 divided by 2. So divided by 2 will give you what? 168. So your answer is 168. So now, how do you use your calculator to solve permutation and combination without all this stress, without going through all this stress? So remove your calculator from complex. How do you do that? Press more than 1. To remove your calculator from complex, just press more than 1. Remember, it was in complex before. So press more than 1. Then see what you do. What you do is this. You see this permutation now. This 5 permutation 4. So this is what you do. This is the approach. So press 5. That is to do permutation. Press the number first. That is your n. Press the number first. So 5. How will you get permutation now? So press shift and press multiplication sign. Okay, then you press your r. Your r here is 4. So 4. What did this give us? 120. Was it not 120 we got when we solved? And you see 120 here. Did we go through the stress of doing all of this? No, we just did it quickly and we got 120. Now let's do for combination. Okay, like I said, let me repeat this so it will not seem as though I'm too fast. So you press 5, you press shift. Then after you press shift, you press this multiplication sign. If you look at it, you see NPR here. Look at combination, NCR. Okay, NCR. Okay, so okay, here we are not supposed to add this 6. It was just, it's supposed to 8 times 7, right? Let's go back and correct this one. 8 times 7 is 56. So it's supposed to be 56 over 2. So 56 over 2 should give us 28. Okay, 56 divided by 2. You know we cancelled it before. Divided by, okay, 28. So 28 is supposed to be our answer. All right, so now, so remember, we have gotten, let me explain this permutation again. So we've corrected this. 56 over 2 is 28. So now let me explain this shortcut for permutation again. So like I said, say 5 shifts, then x, then 4. Look at 120. All right, so now let's do for combination. So combination, you press 8, then shifts and division. This time around you press division. After you press shift, look, and let me do it again. Say 8 shift division, then what? 2. Then 2. What are we getting? Are you saying 28? Which is correct, 28. Okay, so that's the approach. Okay, so that's the approach to doing. Let me explain this combination again. Like I said, combination here, 8 combination 2. So you press 8, press the number first, that is your n, then you press what? Shift, then press division. Remember, see division, and when I press C, it came out. Then press 2 and press equal to, I'm having 28. So this is 28 here. All right, so basically the approach is this. Whenever you want to permutate, you press shift and your multiplication sign. Whenever you want to do combination, press shift and your division sign. That's the shortcut. But ensure you press the number, you press the n first too before you press that shift and multiplication. Then after that you press r. The same thing is applicable here. Press the number, your n first before you press shift and your division, then you press your r. Okay, so that is that. So you can also try this. out. You can try with your calculator 10 permutation 5, and 20 combination 12. So you can try this. 10 permutation 5 and 20 combination 12. You can do the manual and do the calculator shortcut. That is manual. When I say manual, I'm saying do the working aspect, that is the showing working aspect. Then you can also do the calculator shortcut for it. All right, so you can write your answer in the comment box. Okay, I'm just going to give you 10 seconds to do that. All right, just 10 seconds, do that quickly. All right, someone said 10 permutation 5 is 30,240. Let's confirm it. So 10 permutation 5 shift multiplication then 5. Okay, correct. Okay, good. Then combination 20 combination 12. So 20 shift division 12. So 125,970. Good. You're all correct. Impressive. All right, so the next thing we'll be looking at is inverse and composite functions. Inverse and composite functions. All right, so this is a very crucial aspect of functions that you shouldn't ignore. Okay, so basically when we say inverse of a function, remember functions are f of x. Okay, functions are denoted as f of x, and f of x can be, let's say, x plus 2, and this f of x means y equals to x plus 2. F of x means function of x. That's what functions are, actually expressions that contains y depending on x. Y is called the dependent variable, x is called the independent variable. So inverse, now if you look at it, in this case now y is x plus 2, but inverse means making x subject to a formula, unlike here that y is subject to a formula. So inverse of a function is denoted as f inverse of x or y inverse of x. Okay, or just simply y inverse. There's no need putting of x, just simply y inverse, f inverse of x. So but most times if you're having f of x in your question, ensure you just change it to y. They mean the same thing, because you cannot possibly make it subject to a formula like this. All right, you cannot make x subject to a formula when it's like this. So change it to y. Look at what I mean now. If we are told to find the inverse of the following. Okay, so let's say number 1, we have f of x equals to x minus 3. Number 2, we have f of x equals to 2x plus 13. Number 3, we have f of x equals to 5x squared minus 20. Number 4, we have f of x equals to 2 over x plus 8. Number 5, we have f of x equals to square root of x plus or 3x rather plus 9. All right, then number 6, you have f of x equals to 4 divided by x squared plus 3x squared plus 16. Then number 7, we have f of x equal to square root of 4x squared plus 10. Square root of 4x squared plus 10 divided by 20. All right, so we are going to be solving all of these exercises. There are 7 exercises here, of which you are going to be solving. All right, So now let's approach them individually. So like I said, is to make x subject to a formula. All right, so that's the strategy. Make x subject to